Okay, so we're going to talk about our last part of solving absolute value equations, and these are some special cases that we come across. So absolute value, remember, is the distance from 0 on the number line. Can we actually travel a negative distance? If I'm walking, even going backwards, am I really walking a negative distance there? No, not really. So distance can never be negative, okay? So let's think about this mathematically. If I've got the absolute value of x equal to negative 10, what are my solutions for x that will give me out a negative 10? Now, first thought might be, well, 10 and, negative 10, right? If I do the absolute value of negative 10, but that doesn't really work, does it? Because remember, what does absolute value do? It makes everything positive. So it doesn't matter what I plug in there, I'm always going to get a positive number out. So if the absolute value is isolated and equal to a negative number, there is no solution possible. We are not going to have a solution. All right, so let's look at this first example I have here. I've got 3 times the absolute value of x minus 4 plus 21 is equal to 18. All right, so first thing I need to do is isolate that absolute value. So I'm going to minus 21 on both sides, leaving me with 3 times the absolute value of x minus 4 equal to negative 3. Well, then I need to, still don't have the absolute value by itself, so I'm going to isolate that more by dividing by 3. That gives me the absolute value of x minus 4 equal to negative 1. So since my absolute value is isolated and equal to a negative, that is no solution. There's nothing I'm going to be able to plug in for x to give me out a negative 1. All right, let's look at another one though. Similar problem, only there's one slight difference. We'll kind of look how that changes everything. So again, subtract the 21. I get negative 3 times the absolute value of x minus 4. And that's going to equal negative 3. Now again, divide by that negative 3. And I get the absolute value of x minus 4 equals 1. Big difference there with that negative 3 in the front, right? So now I can split it into the two. X minus 4 equals 1, and x minus 4 equals negative 1. Add 4, and I get x is equal to 5. And when I work the other equation out by doing the same steps, I get x is equal to 3. So my solutions are x equals 5 and x equals 3. So that negative 3 out front made the big difference, which is also why we have to get the absolute value isolated before we determine whether it's a no solution or no solution, or if it has 2 solutions. All right, we'll look at one more. I've got 9 plus the absolute value of x plus 5 equal to a negative 6. So absolute value is not isolated, so I'm going to work this one out. I have a positive 9, so its inverse is negative 9. So I get the absolute value of x plus 5 equal to negative 15. Absolute value is equal to a negative. So this is also a no solution. All right, we're going to look at one more. I've got the absolute value of x plus 4 plus 9 is equal to 9. So we need to isolate the absolute value first. So I'm going I'm going to minus 9 on both sides of my equal sign, giving me the absolute value of x plus 4 is equal to 9 minus 9 is 0. Okay, so we're not equal or negative, so we know it's not no solution. And absolute values will never have infinitely many, or at least not the ones we will look at. We don't have infinitely many. So we're at a stage we could split it into our 2. I get x plus 4 equals 0, and x plus 4 equals, I can't do negative 0, can I? So instead of having 2 here, anytime I equal 0, I only have one solution. The only time we get one solution. So I'm going to subtract 4 on both sides, giving me x is equal to negative 4. So special cases that we will be dealing with algebra are no solution or one solution, okay? And the only time you get one solution is if we're equal to 0. No solution is if your isolated absolute value is equal to negative. All right, so that's all I have for this video. We'll see you in the next.